Before we finish up our work with integration by parts, we should look at a quick definite integral here. We haven't looked at one yet. So in this case, I want to integrate the function natural log of x dx from x equals 1 to x equals e. So this one's kind of interesting here. It looks like I've only got the one function, the natural log of x, but and we actually haven't integrated natural log of x by itself. So let's see what this problem looks like. So I know that this is going to be an integration by parts problem. Once I've established that, the first step is, okay, well, what's going to be my u? So u in this problem, the best choice for u, we said, was a logarithm, in this case, the natural logarithm. So u is going to be natural log of x, which means that our dv is everything that's left over. And it looks like there's maybe not anything left over, but I assure you there is right here with that dx. So dv is just going to be dx. This might look a little bit funky, but follow along with me. We will get there. So we've got our u and we've got our dv. So my next step is to, let's go ahead and find du. Du, the derivative of natural log of x is 1 over x times dx for our differential. And then, of course, over here on this right-hand side in red, I need to integrate both sides. Now, what I really have here is 1 times dv and 1 times dx, and that will help us evaluate both sides. I know that when I integrate dv, or 1 times dv, I end up with just v. And when I integrate that right-hand side over there, 1 times dx, I'm integrating with respect to x. So adding 1 to my power, dividing by my power, I get x to the first power divided by 1, or just x. So v equals x. So we have our integration by parts all set up right here. Let's go ahead and write down our formula here. We have u times v minus the integral v times du. So let's go ahead and plug in what we know. We know u is natural log of x times v. V we said was simply just x minus the integral of v. V is once again just x times du. Du is this 1 over x times dx, times 1 over x dx. And the thing that we are going to have to remember is, hey, we're doing a definite integral, so we need to bring down those limits of integration, 1 and e. So I'm going to rearrange a couple different things. I don't really like writing this as natural log of x times x because it becomes perhaps a little bit unclear what's inside of that natural log function. Is it just this x? Is it this x? So I'm going to go ahead and move this x, which is not inside of my natural log function. I'm going to move that to the front. So this will look like x times natural log of x minus. Now, for the second part, this integral, I'm not actually going to go ahead and integrate quite yet because I can simplify this. This is x times 1 over x. When I multiply those out, I'm just going to be left with 1 times dx, which is a whole heck of a lot simpler to work with. Of course, bringing down my limits of integration, 1 and e. So at this point, we're ready to go ahead and find our antiderivative. We've got x times natural log of x minus the antiderivative of 1 dx would just be x. And then, of course, this is a definite integral. This time we don't need our plus c, but we do need to go ahead and plug in x equals 1 and x equals e. So at this point, we're ready to go ahead and evaluate our definite integral. The one thing that is perhaps a little bit tricky is we're not just evaluating this piece right here, but we're evaluating the whole expression right here at our two limits of integration, 1 and e. So we're just going to want to make sure we plug in 1 and e to this whole expression that we found right here. So I want capital F of e minus capital F of 1 for our fundamental theorem of calculus. So capital F of e, that is going to be e times natural log of e minus x. Plugging in x, I just end, or excuse me, plugging in e for x, I end up with e. minus over here capital F of 1. I've got 1 times natural log of 1 minus 1. And then at this point, we have to evaluate this expression. Some of it will end up maybe not looking quite so nice because we have this irrational number e to deal with, but we can simplify this and clean it up. This e right here just going to come down, but we can evaluate natural log of e because the expression that I'm looking at is the same as the base of my logarithm. That will just be times 1. It will simplify to be 1 minus e over here, minus over here 1 times natural log of 1. Natural log of 1 is just 0. Logarithm of any logarithm, I should say, of 1 is always 0, and then minus our 1 over here. So we can simplify this a little bit. We've got e minus e. E times 1 is e, minus e, well, that's just going to be 0. Minus over here, 1 times 0 is 0 minus 1, which will simplify to be negative 1. So to finish this problem up, I've got 0 minus negative 1, which of course simplifies to be positive 1. So the one thing I would be careful of with definite integrals and integration by parts is just making sure that you plug in those limits of integration to the whole expression and not just that second integral after you apply the integration by parts formula.